Hi everyone. In this video, we're going to look at sampling and creating sampling distributions with a small population. When we're creating a sampling distribution with a small population, it's best to look at an example and how you handle it. So I want you to consider this example. There are 25 students in my Year 7 maths class. 13 students are male and 12 students are female. I decide to select a sample of 5 students from the class. I'm going to create a sampling distribution for the sample proportion p hat, number of males in my sample. Hence, I'm going to find the probability that the sample proportion p hat is greater than a half. Then I'm going to find the probability that the sample proportion is less than 3/4, given that it's greater than a half. In this problem, we're dealing with a small population, 25 students. And we know that the number of students with each attribute, the gender, is 13 male and 12 female. Explore the problem and identify the key information. If I'm interested in the number of males in my sample, I could select the following: 0 males in my sample, 1 male, 2 males, 3 males, 4 males, or 5 males. This means that my sample proportion p hat would take these values: 0, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, or 5 out of 5, which is the same as 1. So let's go about creating the sample distribution. My sample distribution will look like this. The number of males in my sample could be 0, 1, 2, 3, 4, or 5. And this means that my sample proportion would be none out of 5, which is 0, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, or 5 out of 5, which is 1. I now need to work out the probability that my sample proportion is each of these values and insert them in the table. So how do we find out these probabilities to insert in the table? Let's look at one example. Let's say we want to find the probability that there are 2 males in my sample. In other words, I want to find the probability that p hat is equal to 2/5. Now, the simplest and most efficient way of finding this probability is to use combinations. I need to work out how many combinations of 2 males that I can select from 13 males. This is equal to 13C2, or in a bracket 13(2). However, I also need to work out how many combinations of 3 females that I can select from 12 females. This is equal to 12C3, or 12(3) in a bracket. And finally, I need to work out how many combinations of 5 students I can select from my total of 25 students. This is equal to 25C5, or 25(5) in a bracket. So finding the probability that p hat is equal to 2/5 is going to look like this. Finding the probability of 2 males in my sample equals the probability that x is equal to 2. And this is the same as finding the probability that p hat is equal to 2 out of 5. Now, the probability of p hat equaling 2 out of 5 is equal to 13 males, how many combinations of 2 males can I select, times 12 females, how many combinations of 3 can I select? The whole thing divided by 25 students, how many combinations of 5 students can I select? I work this out with the aid of my CAS calculator. So I've opened a calculator page in my CAS calculator, and this is the way I do it, although I'm sure there may be a quicker way of doing this. This is how I do it. First of all, I set up my equation. I go to menu. Let's go back. First thing I do is put in a bracket. Then I go to menu. Then I go to probability, combinations, and I find NCR. So the first thing I want to do is put in 12 males. How many combinations of 2 do I want to select? Times, and again, menu, probability, combinations, and now I'm going to select 13 females. How many combinations of 3 students can I select? And then the whole thing over, or divided by, another bracket, and then I have menu, probability, combinations, and it's NCR, 25 students. How many combinations of 5 students can I select? And this is my answer. Now, to find the other probabilities, all I do is I copy and paste. So I've got Control C and then Control V. Now, what I do now is I simply just change my numbers in the numerator. Now, the denominator will remain the same. That'll never change. But if I want to find the probability that there are no males in my sample, I just need to change this to 0, 12 males to choose from. I choose no males, and then 5 females. Hit enter. Here's my probability. Now I do Control V again. And now I find the probability of 1 male and 4 females. Hit enter. And there's my new probability. Control V again. And now I'm going to find the probability of 3 males and 2 females. Hit enter. Control V. Now I'm going to find the probability of 4 males in my sample and 1 female. Enter. Finally, Control V. Probability of getting 5 males and no females. Enter. There is my probability. Very easy with the calculator. So here are all of my probabilities, other probabilities, written in a more mathematical way. Probability that P hat is 0, 1, 3, 4, and 5. Now we can fill in the table. This is what it looks like. So you can see that all the probabilities I just found are recorded in the table under the relevant sample proportions, and my sampling distribution is complete. This table is known as a sampling distribution for the problem. So now let's find the probability that the sample proportion is greater than a half. If we look at the table, we can see that when the sample proportion is greater than a half, It could be equal to 3/5, which is 0.6, 4/5, 0.8, or 1. This means that the probability that p hat is greater than a half will be equal to the probability that p hat is equal to 3/5 plus the probability that p hat is equal to 4/5 plus the probability that p hat is equal to 1. From the table, we can get our probabilities and simply add them together. The answer is 871 over 1,610 or 0.5410. Now let's look at finding the probability that p hat is less than 3/4 given that it's greater than a half. Again, we use our table for this. Now, using the conditional probability formula, the probability of p hat being less than 3/4 given that p hat is greater than a half will be equal to the probability that p hat is between 1/2 and 3/4 divided by the probability that p hat is greater than a half. To find the probability that p hat is between 1/2 and 3/4, we see from the table that there's only one option which gives us this, and it's the probability that p hat is equal to 3/5. 0.4 is too small, 0.8 is too big. So it's going to equal the probability that p hat is equal to 3/5 over the probability that p hat is greater than a half. From the table, this is equal to 286 over 805, the whole thing over 871 over 1610. That works out to be 44 over 67 or 0.6567. So based on what I've just shown you, I want you to now try this example. Stop the video and have a go at doing it on your own. If you've finished doing that example, let's look at the solution. Did you find that p is equal to 0.5? The sample proportion can take the following values: 0, 1/3, 2/3 and 1. The sampling distribution should look like this. Are you correct? And the probability that p hat is greater than 0.5 should be equal to 1/2. This question is question 1 in exercise 17b. So now, based on this video, I'd like you to go ahead and do questions 2 to 4 in exercise 17b. They're just like the example you've just done. Have fun and thanks for watching.